going to step into the new chapter, calculus. The word calculus comes from Latin meaning small stone because it is like understanding something by looking at small pieces. It has two parts. The first one is differential calculus, which cuts something into small pieces to find it how it changes. The second one is integral calculus, which joins or integrates the small pieces together to find how much there is. For example, if you're throwing a stone into a water, what will happen? It will form waves. The waves will resemble a circle. So the radius of the circle changes each and every fraction of second, and at last it will form a big circle. So the rate of change in which the circle has rippled will be found using the differential calculus. At last, the whole area has been formed as a circle that can be used by integral calculus. So, differential calculus is the reverse process of integral calculus, or integral calculus is the reverse process of differential calculus. Limits. Now, what you have learned in your 11th standard that we will recall now. Limits are about approaching. Sometimes you can't work something directly, but you can see what it should be as you get closer and closer. It is like watching a video. Suppose there is a power cut suddenly, you missed a minute video, but you want to know what had happened on that time. You can imagine that it might have happened, but only when you see the continuation of the video after getting the power, you will come to know what had happened at that time. So there should be a continuation, whether it is a serial or whether it is a match or whatever it is, there should be a continuation. Only then you can find what had happened at that time. See here, I have given one example. If a man is running like this, it is like running up a hill and then finding the path is magically or not. Here, he is running up the hill and don't know where to go. But if you only check one side, who know what happens? So we need to test it from both the direction. Only when we test it from both the direction, we will be sure where it should be or what it can be. That is what I told. So limit is used to find the unknown value. We cannot say that we can find the exact value at that place. It is like an approximate value. So you can find the value of undefined or unknown value approximately, not accurately. Then where we cannot find the limit? If it is not continuous, look at the third graph. If it is not continuous, we cannot find the limit or the point of that value. Here they have taken the value as a. I have to find the value of a at this point. Now I am taking the left hand limit. I am getting the point as 3.8. When I am approaching from the right hand side, I am getting it as 1.3, which is entirely different. So algebraically I can prove that limit extend to a f of x does not exist. So when can you find the limit? Can you guess the answer? Only when it is a continuous function, you can find the value of a point using limit. Now, we will move on to the next topic, continuity or continuous function. A function is continuous when its graph is a single unbroken curve. In a simpler way, we can say that you could draw without lifting your pen from the paper. Now, look at the graph over here. This graph I can draw without lifting my hand. When I lift my hand, we can say that the function is not continuous. Now look at the previous graph. I can draw this area continuously, but I have to lift my hand and move to the next point and to continue with the function. So I can say that this graph is not a continuous function, or this function is not continuous. Now, what is a discontinuous function then? Look at the holes in the first graph and the jump in the second graph and the vertical asymptote in the third graph. Here you can see the hole. So I can say that this function is not continuous. Here also the function is not continuous, and here also the function is not continuous because I cannot draw the graph continuously. I have to lift my pen over there and I have to continue with the function here. So these types of functions are called as discontinuous function. What here, first graph, there is a hole. So I can say that it is not defined at this point. Here the limit is not equal. Am I correct, students? The left hand limit will not be equal to the right hand limit. Here the function is continuous at this interval and here also it is continuous, but at that point it does not exist. Am I correct, children? Separately it is continuous, altogether it is not continuous. And also we can say this as it is continuous from this point to this point, as we say in the trigonometric function, and also from this point to this point. At this point it is not continuous. The next is, what is the identification between limits and continuity, or the difference between limits and continuity? How can we find algebraically? Now we know how to find graphically. That is, if a function is continuous, we can draw it continuously. If it is discontinuous, we cannot draw it continuously. Now how to prove this algebraically? How we prove limit in class 11 for a function f of x and a real number a, if limit extends to a f of x exists, if and only if we have to find the value of the left hand limit, you have to find the value of right hand limit. If both are equal, only then you can say that the function is continuous. The limit exists over there. If it is not, we will say that there is no limit, that is, limit does not exist. So now we will move on to the continuous function. In continuous function, how can we prove? When we will say the function is continuous, as we have seen in the examples, when the left hand limit is equal to the right hand limit, and at that point also if it is equal. I am considering a point A. I am finding the left hand limit of that point A, and I am finding the right hand limit of that point A, and at that point also I am finding. If these three values are equal, I can say that it is a continuous function. Now look at this example. If I consider a point over here, this point if I am considering, I will check my left hand limit and I will check my right hand limit, and at that point also I will check. All the three values are equal means I can say that the function is a continuous function. If I will take the left hand limit and the right hand limit, both will be equal, but at that point I don't know what had happened. So I cannot say that it is a continuous function. I can say that limit exists, that is, I can approximately find the value of a function using limit. So this is the method to find limit and continuity of a function algebraically. The next is how to find a discontinuous function. F of x is discontinuous at x is equal to a in each of the following cases. First is f of a is not defined. The second is limit extends to a f of x does not exist. The third is limit extends to a f of x not equal to f of a. F of a is not defined. Can we see the example one more time? Here f of a, at that point f of a, it is not defined. Here the left hand limit and the right hand limit are not equal, so the limit does not exist. Here the limit exists, but at that point it is not equal. Here also limit exists, here also limit exists, but at that point it is not equal. So we can say that the function is not continuous. Understood, children? Limit extends to a, f of x exists, and f of a also we can find the value, but this is not equal. Either left hand limit is not equal to the point at a, right hand limit is not equal to the point at a, you will say that the function is a discontinuous function. Now we will see with some common function. How to check the continuity of the function graphically? If you can draw the function without lifting your pen, it is called a continuous function. Is constant function is a continuous function? Yes. Constant function is a continuous function, and identity function is also a continuous function. The next is polynomial function. Already we have seen about constant function. The polynomial functions of degree 1 is linear function, degree 2 is quadratic, degree 3 is cubic, degree 4 is quadric, and degree 5 is quintic. See here, the linear function is a continuous function and the quadratic function is a continuous function. Cubic function is also a continuous function. Quartic function is also a continuous function and quintic function is also a continuous function. So I can say that polynomial function is a continuous function. So I have found that identity function, constant function, polynomial function are continuous function. Now it's time for you to think and show your strength of understanding the continuous function. Here is your questions for the day. Check whether modulus function, signum function, greatest integer function and the trigonometric functions are continuous and post your answer in the comment section.